Hello everyone, welcome back to my channel. In this video we are going to be learning the topic salt analysis, which is in the chemistry practical syllabus for grades 11 and 12. Now this is part 3 of the salt analysis series, and if you have not yet seen the first and second parts of this series, then I will provide the links in the description box, and I request you to kindly watch those videos first before watching this one. So now let's begin with this video. In this part we are going to be learning the classification of cations, and also we will learn the identification or the systematic tests for the cations. So cations can be classified into 7 groups, from group 0 to group 6. So what are the ions in each of these groups we are going to learn. First, we have group 0, in which we have ammonium ion. We have group 1, in which we have lead cation. Group 2, we have copper, and also we have cadmium. In group 3, we have aluminium. In group 4, we have zinc, and also we have manganese. But manganese I am not going to deal in detail because manganese salts are colored, even copper salts are colored. So copper and manganese, it is not very important, but for copper I will be telling you the confirmatory tests in the next part, because for the viva they can ask you the confirmatory test for copper ion, because it is a very important ion, and you need to know the tests. Then for group 5 we have barium, strontium and calcium, and in group 6 we have magnesium. Now I want to tell you again, just like how I mentioned in the anions video, there are many other cations like arsenic and so on, which I am not going to discuss because in my school we did not actually learn any other cation. These were the ions that we had to learn. But I am aware that the NCERT has mentioned many other cations in the syllabus. So in your school, if they are teaching any other cation, then please let me know in the comments, and I will definitely explain them in the future. So right now I am only explaining these ones because these are the most important ones, and these are the ones which I had learned when I was in grade 12. So I hope in your schools as well they are only doing these ions, but if they are discussing any other cation, then please do let me know and I will surely explain it. So now let's begin with the identification tests. So now for for the cations, just like how I had mentioned for the anions that in all the tests we are using the salt. Like that, for the cations, I am going to tell you, in all the tests, we are going to be using the salt solution. Not the salt, we are using the salt solution. So for the anions, we are using the salt in the identification tests, except for sulfate. And for the cations, we are using the salt solution in all the identification tests. Now for this, for the cations, we are going to begin now with group 0, which is ammonium cation. Now ammonium ion, how will you identify the presence of ammonium? You need to take the salt solution, that means salt plus water, and you need to add sodium carbonate. And if you are not getting any precipitate, if no precipitate is being formed, then that means NH4 plus ion is present, or group 0 cation is present. Now, this is something which we have discussed in the first part under preliminary observations. We have actually done this. So, this is actually something which you should be doing ideally in the first step itself in the preliminary analysis. So, if you are getting no precipitate in the preliminary observation, that means ammonium is present, and that is actually the systematic test as well for ammonium ion. Now we have to discuss group 1. Next, oh, let me change the color because it is quite light. Okay, now we have group 1, that is lead. So now for lead, what is the systematic or identification test? So you have to take the salt solution. Again, I told you we are using the salt solution, and you need to add dilute HCl. Now, when you're adding dilute HCl, if you're able to see a white precipitate is being formed, then that means lead ion is present. It's an identification test. You have to confirm it with a confirmatory test, of course, but this is the identification. If you are getting a white precipitate, then that means lead ion is present in your salt. Now, what is the white precipitate which is being formed? The white precipitate is lead chloride. So, there is chloride ion in the hydrochloric acid that you're adding. So, hence the lead ion will form lead chloride salt, which is the white PPT. Now, we have group 2. Group 2 comprises copper ion and cadmium ion. Now in group 2, we need to just use the solution that we used for group 1. So when you are not getting a precipitate, let's say you're not getting a white precipitate, then you have to ensure that you don't discard the test tube. You have to take the same solution and add H2S to it, H2S gas. So you need to see where there is H2S gas and add the hydrogen sulfide, and if you're getting a yellow precipitate or if you're getting a black precipitate, then that means the group 2 cation is present. If you're getting a yellow precipitate, that means cadmium ion is present. If you're getting a black precipitate, then copper Cu2 positive is present, and the precipitates are cadmium sulfide and copper sulfide or cupric sulfide respectively. Now we have group 3. Now for group 3, you have to take a fresh test tube. So group 3, for group 3, that is aluminium, you need to take a new test tube with just the salt solution. And once you take the salt solution, you need to add NH4Cl, ammonium chloride, and then you need to shake well. After adding ammonium chloride, you need to shake well, because in your lab you will be finding NH4Cl in the form of crystals. It will be a salt, not a solution. So you need to shake well so that the crystals of NH4Cl break down and they dissolve in the solution. And after that, you need to add NH4OH. So you have to add NH4OH, and after doing this, if you are getting a white gelatinous precipitate, then that means aluminium ion is present. Okay, the precipitate has to be gelatinous. That means normally your precipitates, the precipitates will be thick and it will be together. But when I mean gelatinous, gelatinous means it has to be kind of separated, like disjointed areas. So if this is your test tube, then your white precipitate should look like this. Okay, it should not be a continuous precipitate. You should be able to see some gaps in between. It should be gelatinous, and that means aluminium ion is present. Now, the white gelatinous precipitate that you're getting is aluminium hydroxide. Now, normally we think that it is aluminium chloride because of NH4Cl, but no, it is actually AlOH thrice, which is aluminium hydroxide. Next, we have group 4. Now, for group 4 and for group 5, you need the group 3 test tube, as in the substances in the group 3 test. So what you need to do is, if you are not getting a white gelatinous precipitate, you need to move on, because I told you for the identification test it has to be systematic. I had told that in the first part. It should be a continuous test where you need to identify, as in you have to perform all the tests until you get a positive result for one of the ions. So if you are not getting a white gelatinous precipitate, you have to keep moving on to the next one. So hence you have to take this test tube, the solution in the test tube, and you can divide it into two halves. So divide it into two halves. In the first half, you have to pass H2S gas. Pass H2S gas through it, and if you are getting a dirty white PPT or a buff colored precipitate, then that means group 4 is present. Now, what is the dirty white PPT? The dirty white PPT is zinc sulfide, and the buff colored precipitate is manganese sulfide. So the zinc sulfide formation indicates the presence of zinc, and manganese sulfide indicates the presence of manganese ion. So if you're getting one of these precipitates, that means group 4 is present. So when I say divide it into two halves, you just need to take another test tube and add some of the white gelatin, not white gelatinous, I meant the solution which I have circled, that you need to add like half of it to another test tube. So in one of the test tubes, you're going to pass H2S gas for the group 4 test. And let's say the group 4 ions are not present. Then you need to move on to group 5. So for the group 5 test, in addition to all these substances, you need to add NH4 twice CO3, that is ammonium carbonate. So you need to add ammonium carbonate to it, and when you are adding the ammonium carbonate solution, if you're getting a white precipitate, a white colored precipitate, that means group 5 is present. Now, very important, the white precipitate only indicates that the group 5 ion is present. It does not give you a clear idea as to whether it is barium or strontium or calcium, because actually the white precipitate formed is a carbonate precipitate. So it is either barium carbonate or strontium carbonate or calcium carbonate. Now the problem is all the three carbonates are white in color. So as a result, you cannot get a clear idea as to which ion is present, but you can conclude that a group 5 ion is present. So you need to do another test in addition to this, which I will be explaining in the next part, because that is a confirmatory test. And if you are getting the desired result, then only will you be able to identify the exact cation. So I hope that is clear. Now we have to do the group 6 ion. Now for the group 6 ion, actually you can just see if all the above ions are absent, and if all of them are absent, you can say that group 6 is present, which is magnesium, Mg2 positive. But if you are required to do a test in your school, you can do the dihydrogen phosphate test. So you need to take the salt solution and you need to add dihydrogen phosphate. Dihydrogen phosphate to it. And if you are getting a white precipitate, that means magnesium is present. It is not a confirmatory test, it's just an identification test. You can also add NH4Cl and NH4OH as well to do this, but normally we just add ammonium dihydrogen phosphate. Sorry, I forgot ammonium. I meant ammonium dihydrogen phosphate. Okay, so you have to add ammonium dihydrogen phosphate, and if you're getting a white precipitate, that means magnesium is identified. So these are the identification tests, and I hope you have understood all of them. So if you have any doubts, then please feel free to comment and I will surely respond.